Hello students, welcome to Educate. In the last class, we have discussed about the limiting reagent. During the discussion of stoichiometric calculation, and we have also solved one question. So then after we will discuss the how to solve the one to different types of questions also related to stoichiometric coefficient, and then after about the reactions in solutions. Here is a topic balancing a chemical equation. About that, let's discuss. First of all, discuss about that. Then after a few questions, there is concepts already we have discussed in the previous class. Now, so one, two more questions about that we will also discuss. I hope if other type of questions you have solved and you have not felt any difficulty. So now firstly here, balancing our chemical equations. Balancing our chemical equations, usually students don't feel difficulty, but someone due to the tension, someone feel difficulty to balance. That means he take time, he or she will take time. But here I am telling you how to solve this one. First one is about here balancing. This equation is already balanced. So here about that we shall not discuss. This equation is already balanced here. This equation is not balanced. So about that we firstly discuss how to balance this equation. Let's see here. That means about this equation we are balancing. We will balance this equation. This one. Okay. What happened, guys? There is a method of hit and trial method. One is that, and second one in the 11th class examination, if there will be questions related to stoichiometric coefficient, then simple equations will be provided. But when you will appear in the NEET examination or in IIT main examination, there will be reactions which you could balance by the oxidation number method or by the half reaction method. That is, if you will not have an idea about the redox reaction, then you will feel a lots of difficulty to solve the questions of the problems based on stoichiometric calculation. So first of all, let's hear about the hit and trial method, which is more important for you for the 11th class and for the IIT main and advanced. This one will be just like the ABCD. Okay, so let's see here. The question is here, this one. Here 4 phosphorus, here 4 phosphorus. Here 10 oxygen, here 2 oxygen. So simple it is. Balance here 5. So 5 to the 10. One is here. Why we balance the chemical equation? Due to law of conservation of mass. Recall the previous lecture. So we balance the chemical equation by considering the law of conservation of mass. Since the mass of product will be equal to mass of reactant, so we balance the chemical equation. So let's see here. This equation already balanced. Then what after is another question. This one is asking here. Okay, this one balanced equation. This has been balanced. Then NCERT book that has been given. Now there is let us combustion of propane. About that you will have to balance. You will have to write a balanced equation for the combustion of propane. So what's the meaning of combustion? Combustion means that substance will be heated in presence of oxygen. So that will be combustion. So very simple it is. So first of all, let's see. So I am here making this short and then after balance here. So combustion of propane you will have to discuss. So propane is C3 H8. This one combustion means that will be heated in presence of oxygen. So there will be formation of 3 moles of, when combustion will be there, then here, that means you should also predict what will be the product. Reactions, when you will study the chemistry, then what will be the reaction, that you will be able to predict by yourself. But even though I am telling you the shortcut method, the trick by which you could predict what would be the product during a reaction. So here there is oxygen is combining with propane. So propane composed of carbon and hydrogen. So oxide of carbon and the oxide of hydrogen both will form. So oxide of carbon, what is here? Carbon, so that is CO2, and that of hydrogen, that is H2O, well known. How that is? Because carbon plus 4 and oxygen minus 2. You will have to make charge equal. Oxide of carbon, that means here carbon and oxygen will combine together. So carbon here will show positive oxidation state. Since oxygen is negative, more electronegative than carbon, so here oxygen will acquire negative charge. So carbon will have to show positive charge, and you will have to make the charge equal. So that is possible when you will multiply by this, the 2. So CO2 will form. Someone may think that carbon monoxide also form, but carbon monoxide forms when there will be incomplete combustion of the carbon or any other substance. If there will be incomplete combustion, then carbon monoxide forms. But if there will be complete combustion, then CO2 forms. So here that's why CO2 will form. So when propane reacts with oxygen, so first of all, okay, let's see first the reaction. So there will be formation of CO2, and what about the hydrogen? Hydrogen plus 1, because 1 electron only, and oxygen minus 2. So you will have to make charge equal. So that's why 2 hydrogen will combine with 1 oxygen. The 2 hydrogen will combine with 1 oxygen, and there will be formation of water. Okay. After the combination, what will be the product, that you can predict by this one. What's the valency of that element, like carbon and oxygen? So according to their valence, by considering the valency, you could find out what would be the product. Okay, about that I think you are already aware. Somehow you have studied in the 10th class. So even though if not studied, and if this topic you have any difficulty, so maybe this difficulty will get rid out. So now that one, now balance that. So what balance here? There is 3 carbon. So 3 carbon here. Hydrogen how much? 8. So here 2 hydrogen. So there will be 4. Now let's see about the oxygen. How much is here? So 3 to just 6 and 4. That is 10 oxygen here is. Number of oxygen atom is 10. Here is 2. So that's what? 5. So that means one molecule of 1 mole of propane will react with 5 mole of oxygen and will form 3 moles of CO2 and 4 moles of H2. That was okay, guys. So now let's see here some questions based on stoichiometric. That means here some questions related to stoichiometric calculations. Like this question. Let's see. There is, and you will have to find out amount of water produced by the combustion of 16 gram of methane. So let's see here. Where is it here? So methane is here. That is combustion of methane will be there, and as a result it has been provided that water will form, and it's asking how much water will form. Okay, and the amount of methane has been provided. The amount of methane has been provided. So simply write the reaction. So methane, that is CH4. Combustion means that will react with oxygen. So that will react with oxygen. So there will be formation of the compounds of carbon, and that means oxide of carbon and that of hydrogen. So carbon here plus 4 valency and oxygen minus 2 to make charge equal. That means 1 carbon will combine with 2 oxygen. So there will be formation of CO2. Same for hydrogen. because here is carbon and hydrogen. So oxide of carbon and the oxide of hydrogen will have to form. So carbon, that forms CO2, hydrogen plus 1 oxidation state, oxygen minus 2. So you will have to make charge equal. So 2 hydrogen will combine with 1 oxygen. So there will be formation of H2O. Now balance them here. Here 1 carbon, so 1 carbon. 4 hydrogen, so here will be how much? 2. Balance that oxygen. Here 2 oxygen, here 2 oxygen. 4 oxygen, so here 2. So this one is the balanced chemical equation when methane, the combustion of methane will take place. Then that will form. So watch out here. 1 mole methane. Here stoichiometric coefficient is 1. Here 1 and here stoichiometric coefficient is 2. Here stoichiometric coefficient is 2. Here nothing means, that means 1. Here nothing means 1. So one molecule of methane gives 2 molecule of water. Or in other word, 1 mole of methane gives 2 moles of water. So let's see here. Methane here, so methane here 1 mole methane means how much weight there will be? So 12 for carbon and 4 into atomic weight of hydrogen as 1. So 4 minus 1, that is 16. So 1 mole methane or 16 gram methane. Here you will have to establish the relationship between methane and that of water, because amount of methane has been provided. Here the amount of methane has been provided and the amount of water is asking. So you will have to consider about the relationship between that of methane and that of water during the reaction. So here 1 mole methane gives 2 mole water. So 1 mole methane, 1 means here methane means their molecular weight, and molecular weight is here 16. Molecular weight of methane is here 16 U. So 1 mole methane or 16 gram, molecular weight of methane is 16. That means when the number of moles of methane will be 1, then their weight will be 16 gram. The molecular weight of methane is 16. That means when the number of moles of methane will be 1, then their weight will be 16 gram. So 1 mole methane or 16 gram methane gives how much? Here 2 mole water, or here 2 into molecular weight of water will be how much? 2 for hydrogen, and here 2 into 1 plus 16, that is 18. 2 into 18 means 32. So that gives 2 moles water or 32 gram water. Question is asking 16 gram methane gives how much? So 32 gram water that will give. Simple here. Oh, sorry. 18 to the 36, not 32. So 36. Okay. So that means 1 mole methane or 16 gram methane gives 36 gram water. Let's see about this question. Read the question here. Question is, how many moles of methane are required to produce 22 gram of CO2 after combustion? So that means here methane is a combustion of methane will have to take place, and you will have to produce CO2. That means the demand of the question is you will have to produce 22 gram of CO2, and for that the 22 gram of CO2 you will have to obtain by the combustion of methane. So how much methane you will have to take, the question is asking. In the question is asking that when 22 gram of CO2 will have to produce by the combustion of methane, then what will be the amount of methane required to produce 22 gram of CO2. So let's see here. So firstly, you will have to write the equation for that. So methane here, So methane, that's combustion means react with oxygen. So that will form oxides of carbon, that is CO2, and that of hydrogen, that is H2O. Balance the equation. So here 2 and here also 2. Okay, you will have to produce carbon here already. So carbon here, molecular weight will be how much? Molecular weight of CO2 will be 12, because atomic weight of carbon 12, plus there is 2 oxygen and atomic weight of oxygen is 16. That will be 44. So that means here this amount is given 44 gram, here 44, that is molecular weight, and of methane here is how much? Carbon 12 and plus 2 here for the hydrogen. Oh, sorry, 4 for the hydrogen. So 4 into 1, that is 16. So molecular weight of methane is 16. So 44 gram of here CO2, because 1 mole CO2 is produced by the combustion of 1 mole methane. 1 mole CO2 produced by 1 mole methane. One mole methane means here their molecular weight. 1 mole CO2 means their molecular weight. That means here 44 gram of CO2 will give produced by 16 gram methane. 44 gram CO2 will produce by 16 gram methane. So that means 44 gram CO2 produced by 16 gram methane. So 1 gram CO2 will produce by how much? 16 by 44 gram methane. And question is asking 22 gram of CO2 you will have to produce. So 22 gram of CO2 will produce by how much? So 22 gram of CO2 will produce by 8 gram methane. That is okay, guys. Very easy. Now let's see again. Watch out this question. 50 kg of nitrogen react with 10 kg of hydrogen. This one, okay, let's see here. 50 kg nitrogen react with 10 kg hydrogen and produces ammonia. You will have to find out the amount of ammonia formed, identify the limiting reagent in the production of ammonia in this situation. So write the reaction here. Nitrogen react with hydrogen and there is formation of ammonia. Amount of nitrogen given 50 kg. Amount of hydrogen that is given 10 kg. Okay, so let's see here. When you watch out the equation, you will find out that 1 mole of nitrogen react with 3 mole of hydrogen. 1 mole nitrogen react with 3 mole hydrogen. So here 1 mole nitrogen means how much? 1 mole nitrogen react with 3 mole hydrogen. So number and here amount of nitrogen is here 50 kg. So in that case you find out the number of moles and here hydrogen also. So goes of the question. Nitrogen means atomic weight 14 and there in one nitrogen molecule there is 2, so that is 28. And hydrogen how much here? That will be 1 into 2, that is 2. So 1 mole nitrogen react with 1 mole nitrogen reacts with okay. 1 mole means how much? That is 28 gram. So 28 gram nitrogen. 3 into 2, because here 2, that means 3 into 2, that means 6 gram hydrogen. 28 gram nitrogen reacts with 6 gram hydrogen. Here is how much? 50 kg hydrogen is there. So 50 kg nitrogen is given. So 50 kg nitrogen, so how much will be there? So 1 gram nitrogen reacts with how much? 6 into 26 upon 28 gram hydrogen. Number of moles is here 50. So 50 into 10 power 3, that much. Gram nitrogen reacted with how much? This one. Calculate this one. How much? That will react with 10.71 into 10 power 3. That much gram hydrogen. In kg, that will be, or that will equal to 10.71 kg. That is 10.7. That means nitrogen, how much nitrogen has been provided, that much nitrogen requires 10.71 kg of hydrogen. To react the nitrogen completely, 10.71 kg of hydrogen will require. But that much hydrogen is not available. Hydrogen is only 10 kg. So what will happen? Here 10 kg hydrogen is only there. So 10 kg hydrogen here. So that 10 kg, this hydrogen will completely consume during the reaction, and the nitrogen, some nitrogen will left. So 10 kg hydrogen will give the reaction product form, and the remaining amount of this nitrogen will left during the reaction. Here, so that means how much ammonia will form? Here, since hydrogen will consume completely during the reaction, so how much ammonia will form, that will depend on the amount of hydrogen. How much ammonia will produce, that will depend on the amount of hydrogen, and that's why in this case hydrogen is the limiting reagent. Okay guys? Okay, guys, this one here, how much? Because that much hydrogen is not available. So that much not available. So that will limit the reaction. Now, how much ammonia will produce? That will depend on the amount of hydrogen. So let's see how much ammonia will produce. Let's discuss about that. Here 3 mole hydrogen. Three mole means how much? 3 into 2, because hydrogen molecular weight 2. So that much gram, 3 into 2 gram H2 produces. How much? 2 into here 17, nitrogen 14, and 3 into 1 17. So 1 gram hydrogen will produce how much? Sir, is 10 kg. That will be here. That is 56.6 kg ammonia will produce by 3 kg. That means 56.6 kg of ammonia will produce by 3 gram of that much by this reaction. Here, okay. You may check that also. We will see 56.6. So that's came or not. Okay, approximately same, because there will maybe some calculation error. So that is this one. Okay, guys, this question was very easy, not difficult. Now let's see another type of question. You here just say, watch out. There's another type of question will be in that size. About that we will discuss after finishing this chapter. Now first one, let's see. Here is reactions in solutions. In that one case is first one is about mass percentage or weight percentage, and that is indicated by W by W percent. Mass percentage or weight percentage, that is indicated by W by W percent. Mole fraction, molarity, and molarity. Okay, about that let's discuss mass percentage. Okay, so I'm zooming here. First one here is mass percentage. Okay, guys, in the examination question may ask in the 11th class that define mass percentage like that. The meaning of percentage is if total amount is 100, then what is that amount? That means just like that, you know about the mathematics about the profit percentage, about the loss percentage. Profit percentage means if an investor will invest rupees 100, then how much amount he will gain. That will be their gain percent or profit percent. In the same way, if a shopkeeper have uh, bought any sub article in the cost of 100 rupees, then how much amount he have suffered, that will be called their loss percentage. Okay, so in the same way here, mass percentage means when the total mass of the solution will be 100 gram, then what will be the amount of that solute or the solvent? That will be called mass percent of the solute. Let's see here. Mass percent means the mass of solute or the solvent when total mass of the solution is 100 gram. Let's see here. If you will have to find out mass percentage, so mass percent W by W percent. So mass percentage of solute when you will have to find out. So that you will have to take mass percentage. That means mass of solute upon total mass of solution into 100. So that will be equal to okay guys, but you will have to watch out. The total unit should be same. So mass percentage of solute will be equal to mass of the solute in gram, mass of solute in gram, that upon total mass of solution in okay guys, any problem here? In the same way, let's see mass percentage of solvent can be also find out. Okay, let's one thing more. In the solution, there will be solute and the solvent both. So total mass of the solution will be equal to mass of solute plus mass of solvent. So that can be also written as mass percentage of solute. That can be also written as mass of solute in gram, that upon mass of solute plus mass of solvent in gram. So that will equal to so that is mass percentage of solute, like that you can find out this one. Same, if you will have to find out mass of the solvent. Okay, in a solution, what is solute and what is solvent? Simple that is. So solute, and before that, what is solution? What is solution? Okay, about that, you know already that when you dissolve the sugar in water, when you dissolve sugar in water, then the sugar will uniformly distribute in the water. The sugar will uniformly distribute in the water. That means here, just like if it is a container here, so in this one there is water and you have dissolved sugar. So sugar here. So during this case, what will be the sweetness at the upper portion? That will be also equal to the sweetness at the lower portion. So what this one? Here sugar and water has been uniformly distributed. So amount of sugar per particles of the water present here, that will be also here and that will be also here. So that is solution. But if you mix a sand and the salt or sugar here also, so here composition of sand and the sugar will be not same throughout. So this is not a solution. This is not a solution. This is not. But this one is a solution of sugar and water. That is a solution because the composition of the solute and the solvent, that is same throughout. So solution is the mixture whose composition remains same throughout. You may write that. Solution is the mixture whose composition remains same throughout, or solution also called homogeneous mixture. Homogeneous mixture means, that means its composition is same throughout. So that is solution. So mass percentage of solute, when you will have to find out, then that will be equal to mass of solute in gram, that upon total mass of solution in gram into 100. And in the solution there will be the mass of solute and the mass of the solvent. So that is mass percentage of solute, that will be also equal to mass of solute in gram, that upon mass of solute in gram plus mass of solvent in gram into 100. That is. Now in the same way, if you will have to find out mass percentage of solvent, as you have find out the mass percentage of solute, like the same way you can find out mass percentage of solvent. Let's see here. So mass percentage of solvent, that will be equal to mass of here, mass O, as you have written, mass percentage of solute equal to mass of solute in gram, that upon mass of solute plus solvent in gram into 100. In the same way here, so mass percentage of solvent will be equal to mass of solvent in gram, that upon total mass of solution in gram. So mass percentage of solvent will be equal to mass of solvent in gram, that upon total mass of solution in gram, and the total mass of solution will be equal to the mass of solute plus mass of solvent. So that can be also written as, so mass percentage of solvent, that can be also written as mass of solvent in gram, that upon mass of solute in gram plus mass of solvent in gram into 100. Okay guys, now predict what will be the unit of mass percentage. Here gram will cancel out. So when gram will cancel out, so it will have no unit. So Listen now, this one was about the concept. Now let's see about this question. This one, a question is okay. So in this question, what is that here? In the question, it is telling that 2 gram of a substance has been dissolved in 18 gram of water. And so what will be the mass percentage of the solute? Question is asking that when 2 gram of a substance is dissolved in 18 gram of water, then what will be the mass percentage of solute? Okay, so very easy here. Not 2 gram solute dissolved and water here 18 gram. So total mass of the solution will be how much? 18 gram plus 2 gram, 20 gram, and mass percentage will be 18 gram upon 20 gram into 100. That you will have to find out. Very easy it is here. So directly, who rely more on the formula may apply the formula. Who rely more on the concept, apply the concept. But I suggest you that you rely on the concept, because when you will mug up the formulas, that not necessary that you will solve the questions. Let's see here. So mass of solute will be how much? 2 gram, and mass of solvent will be 18 gram. So total mass of solution will be how much? It is asking mass percent of solute. So mass percent of solute will be how much? So mass of solute here is 2 gram. So that will be 2 gram upon mass of total whole solution is 20 gram. So 20 gram, that into 100. Gram cancel out. 2 divided by 10. 10 here, this one. So mass percentage of solute will be 10%. So that is equal to 10%. That is clear? Anyone tell what will be the mass percentage of solvent? So here it's the binary solution. Binary solution means in this solution there is only two components. One the solute and other the solvent. So it's the binary solution. So when we will add the percentage, mass percentage of solute and the solvent, that will become 100. So mass percentage of solute is here 10%. So mass percentage of water will be 90%. You will write that. So here question, demand of the question is not about the mass percentage of solvent, that is water. So you may write, you may not write. But I am telling you here, if you will have to find out the mass percentage of solvent, so no need to go through these formulas like that. You just think that since it's the binary solution, in this solution there is 10% solute. So mass percentage of solute will be 100 minus 10, that is 90. Now let's watch out the next term, that is mole fraction. Mole fraction. Fraction means out of 1, and mole fraction means when the total number of moles of the solution will be 1. Okay, then what will be their number of moles of that component? So that means here mole fraction means when the total number of moles of the solution will be 1, then what will be the number of moles of that component? So let's see here. So mole fraction here already given, formula is given here, I am not writing. So that is equal to, there is two component A and B. There is two component A and B. So mole fraction of A, if you will have to find out, so that will be equal to number of moles of A, that upon number of moles of solution, and in the number of moles of solutions when you will have to find out, so that will be equal to number of moles of A plus number of moles of B, because there is two component A and B. A and B, there is two component. So number of moles of solution will be equal to number of moles of A plus number of moles of B. Number of moles of A has been indicated by Na, and number of moles of B has been indicated by Nb. So mole fraction of A will be equal to Na upon Na plus Nb. In the same way, when you will have to find out mole fraction of B, so that will equal to number of moles of B, that upon number of moles of solution, and in the solutions, the number of moles of solution will be equal to number of moles of A plus number of moles of B. So that's why here Nb upon Na plus Nb. Okay, mole fraction of A, that can be indicated by chi A. Mole fraction of A, that can be indicated by chi A. And the same way, mole fraction of B can be indicated by chi B. Okay, for the binary solution, keep in the mind, if there will be calculation numerical question, there will be, if Na will be given and Nb will ask, then no need to go through the formulas. No need to go through the formulas. If that will be the binary solution, then Na chi A plus chi B will be equal to 1. So from binary solution, then after is molarity. So what's the molarity? Molarity is telling that if the total volume of the solution, will be 1 liter, if the volume of solution will be 1 liter, then what will be the number of moles of solute? That will be called molarity. Molarity means the number of moles of solute present in 1 liter solution. So molarity means this one, and that's indicated by capital M. So molarity, here definition I am writing here, molarity, that is indicated by capital M. So molarity is the number of moles of solute present in 1 liter solution. That is molarity. And its formula here. So molarity here is formula is number of moles of solute upon volume of solution in liters. Guys, keep in the mind here, total volume of whole of the solution. When a solid dissolves in a liquid, the total volume of the solution will remain unchanged. When a solid will dissolve in a liquid, then the volume of the solution will be constant. How? Because suppose there is a liquid water here. There is a liquid. So in the liquid, the distance between the particle is more. You already know about that. Suppose this is the water particle. This is the particle of water. And when you dissolve sugar, so suppose that will come here, that will come here, that will come here. So there be no increment in the distance between the particles of this solvent. When a solid will dissolve in a liquid, then there be no difference in the distance between the particles of the solvent. That's why volume don't change. In other words, when a solid dissolves in a liquid, then the volume of the resulting solutions don't change because the solid solute particles enter inside the intermolecular spaces of the solvent. Okay, you may write that when a solute dissolves in a liquid solvent, then there will be no change in the volume of the resulting solution because the particles of this solute penetrates inside the intermolecular spaces of the solvent. Okay, that is. So now when you will have to calculate the molarity, so here number of moles, in that case we considered about the number of moles of solute by and the volume of whole of the solution. Whole of the solution here. Okay guys, keep in the mind that is. So what about this unit here? So number of moles of solute, its unit will be mole. So here its unit will be mole and its unit will be in liter. So unit will be mole per liter. So unit of molarity is mole per liter. So write that unit of molarity is mole per liter. That was about the molarity. Now let's see. Then after is molality. Now then after is molality. So in molality, we will have to consider the mass of solvent. Keep in the mind, mass of only solvent. So molality is the number of moles of solute present in 1 kg solvent. Molality is the number of moles of solute present in 1 kg solvent. Molality, that is indicated by a small m. A small m. Molarity, that's indicated by capital M, while the molality indicated by small m. That is here also formula is written here. Molality, that is indicated by small m here. So this molality equal to number of moles of solute that upon mass of solvent in kg. Okay. Now predict what would be its unit. So number of moles of solute, whatever be that number of moles, the unit is mole and weight here is solvent, weight of solvent in kg. So that will be in kg. Keep in the mind here, during molarity, we have considered the volume of whole of the solution. But during the calculation of molality, we will have to consider the mass of only solvent, and not whole of the solution. Okay, so that is molality. So that was about the problem about the reactions involving solutions, their concept required. In the next class, we will discuss about the numerical questions asked on this concept. That is, the calculations involving solution. So that will be the next class. So it's all for this class. Thank you, Team Educate.